Solving linear systems with two equations and two variables by substitution. So this is another method used to solve linear systems. And how this works is given two equations. So say for example, we're given x equals 3 plus 2y and 4x minus 3y equals 32. The first thing you want to do is take one of the equations and solve for one variable. It actually doesn't matter which one you pick, which equation, and which variable. Whatever makes the most sense to you or is the easiest. So in this case, we already have our top equation given to us solved for x. So let's use it so that we can cut down on work. So what we're going to do is take what x equals, this piece, and plug it in for x in the other equation that we were given. So instead of 4x, we're going to have 4 times what x is equal to. Well, x is 3 plus 2y. So instead of x here, we have 3 plus 2y. Minus 3y equals 32. Now you're going to take this equation and solve for the variable that's left, in this case y. So we're going to distribute the 4 through and get our new equation. Combine like terms and then get y by itself. Dividing by 5, lastly, we get that y equals 4. So now we take this and we plug it into either one of these equations and solve for x. The nice thing about plugging into this equation is that it's already solved for x, so we just have to plug it in on one side and we don't have to manipulate things after. We can say, well, x equals 3 plus 2 times y. Well, we just found out that y is 4. So x equals 3 plus 8, or 11. So the point 11, 4 would be the place where these two lines intersect on a graph. We could verify this by graphing them, or we can plug this point into both equations and it would make a true statement. So say for example that I'm given the two lines 5x plus y equals 7 and 3x minus 2y equals 25. So in this case, I'm not already solved like I was up here for one of my variables. They're both on the same side, so I'm going to pick one. Well, looking through these 4, I noticed that this y has a 1 in front of it. So it's probably the easiest to solve for. So I'm going to take this equation and solve for y. I could actually pick any of them and get the same answer. Sometimes I'll just make things a little more complex before it gets simpler. So taking 5x plus y equal to 7 and solving for y, I subtract 5x to both sides and I get y equals negative 5x plus 7. Now that I know what y equals, I'm going to take it and plug it in for the y on the other equation. So I get 3x minus 2 times y. Well, y is equal to negative 5x plus 7 equals 25. Solving for x now, we get 3x plus 10x minus 14 equals 25. 13x minus 14 equals 25. Add the 14 over. 13x equals 39. Divide both sides by 13. And x equals 3. So taking this now and plugging it in for x here, we're going to find out what y is. Well, y equals negative 5 times 3 plus 7. Y equals negative 15 plus 7. Y equals negative 8. So the point 3, negative 8, is where these two lines intersect. So let's recap the steps just so we know them. Take one of the equations, pick a variable, solve for it. Take what you got as the solution, plug it in for the same variable in the other equation. Solve for the variable that's left. Take that solution and back substitute it into your first one you solved for and solve for that second variable. Now you have an ordered pair where these two lines cross. Let's try a third one. So our last example. This one's a little more complex, being that it involves fractions, so it looks a little bit intimidating at the first. But there's actually a trick to make this a little bit nicer. So say we were given these two equations. Looking at this, I'd be like, oh, which variable do I solve for? And fractions. Like, I would be intimidated. So the first thing we can do is multiply that top equation with the fractions by their common denominator, and this way we're actually going to get rid of the denominator. So we know that both 10 and 5 go into 10. So I'm going to multiply the whole thing by 10. Multiplying the first one by 10, I get 10 over 10, which means I'm left with 1x. So my new equation becomes 1x, or just x. Multiplying this by 10, I get negative 30 over 5, or negative 6y. Multiplying this one by 10, I get 20 over 5, which is equal to 4. So multiplying this whole equation by 10 makes it look like this. A lot simpler than those fractions. So then I look at these two equations and say, okay, which variable am I going to solve for? In this case, this x has a 1 by it in front of it. So I'm going to solve for this variable because it looks like it'd be the simplest to solve for. So I'm going to add 6y to the other side and get x equals 6y plus 4. Now, remember, take this, plug it into the other equation. So I get negative 2 times, instead of x, 6y plus 4 plus 3y is equal to 1. Distribute through and I get negative 12y minus 8 plus 3y equals 1. Negative 9y minus 8 equals 1 by combining like terms. Add the 8 over, negative 9y equals 9. Divide by negative 9, and y equals negative 1. Taking this, plugging it in to our first equation, x equals 6 times negative 1 plus 4. X equals negative 6 plus 4, and x equals negative 2. So the ordered pair of negative 2, negative 1 would be the location where these two lines intersect.